Today, we will be understanding the advanced pandas, and in that, we will be understanding three most important functions. If you understand these three functions, then I would say you will be able to perform 90% of the pandas operations. And when you want to merge like vertically, right? So you can use the axis equals to 1 and the data frames will be concatenated vertically, right? So this is the axis 1, you can say, and this is axis 0, right? Even like with the welcome again to day 29 of the 100 days of hell with Python algo trading. And why again? Because I'm recording this video again of day 29 because in the previous video I thought the length of the video is very short, and also I was not satisfied with the video quality, the content of the video quality. So I would like to apologize for that, and I'm sure that you will find today's video much more valuable, much more insightful, and much more useful. Today we will be understanding the advanced pandas, and in that we will be understanding three most important functions. If you understand these three functions, then I would say you will be able to perform 90% of the pandas operations, because this will include all your basic understanding. So for that you have to have a basic understanding of pandas, and really these methods are really important because in real life scenarios you will be using these methods a lot. While fetching data from any exchange, you will have to use these methods. Even while working with databases, you will have to use these methods. And also, one exciting update that previously I received so many messages that please use the real data. So today, on your request, going forward, we'll be using all the real data. We'll try to fetch the real data from the exchanges or from any source, but it will be real data. But sometimes in some exceptional cases, we still have to use the synthetic data to show you, to demonstrate you. So for that, we can't do anything. But if you still have any solution, you can let us know. Then you should be able to apply that concept in your real life algo trading scenarios, right? That is our main goal. So without a further ado, let's get started. These three methods are merge, join, and concatenate. Basically, when we see all these three methods perform almost the same operations, but these three methods have their own use cases. You can use them interchangeably, and also many times a lot of people gets confused between these three methods, that what should we use at which place. So we will clear that confusion today completely, entirely. After this session, you will be not having any confusion that which method you should be using at which place. Okay, so with that being said, let's get started. So the first method is merging. It is similar to joining. So let's understand that definition. It combines two data frames based on the common column or indices, right? It supports different types of joins: inner, outer, left, and right. Then it uses the pd.merge function. So here the takeaways are the merging combines with the common column or indices, and it has four types of joins: inner, outer, left, and right, and it uses the pd.merge function. Okay, now let's understand the use cases in algo trading. So we can use merging for combining the historical data. So merge historical price data from different sources based on a common date column, right? So we'll be doing this a lot. Then again, integrating indicators. So merge technical indicators calculated on the same index or stock using the date or timestamp as the common column. So on the base of that date or timestamp, we can combine multiple data frames. Now, it can be used for enriching data. So merge additional data such as fundamental data, example earnings, dividends, with price data to create more comprehensive data sets for trading algorithms. So sometimes you will be having the technical data. So you would like to find the mathematical and technical relation between the prices and the fundamental data, right? So actually in trading, you have to find some common thread that why the price is increasing or decreasing. And if you find that even a little bit, you are having an edge. You know that, right? Next. So merging is done, and we can say it is similar to joining. Why? Because you will be able to perform almost all the operations which you can perform with the join function, with the merge. But now let's understand joining also, and after that you will realize that it's almost the same. Now we have joining. Definition. Joining is conceptually similar to merging, but typically refers to the method of combining data frames based on their indices using the join method. So in the merging, we have the common column or indices, but in joining, it has only the indices, right? So we can use the join method. This method also supports inner, outer, left, and right joins. So the similar thing is that in merge and in join, we have the inner, outer, left, and right. The same thing, exactly same. But in merge, we can combine with the common column or common indices, but in join, we can only combine with the common indices, right? So the types are exactly the same, the inner, left, and right, and outer. So don't worry, I'll explain you all these types of joins in a bit, because these are common in both the joining and merging method. So before that, let's understand some use cases in algo trading of joining method. So inner join, it can be used for combining datasets where only common entries are needed, right? For example, combining stock prices with sentimental data where you only care about dates where both data are available, right? For left join, it can be useful when you want to keep all the entries from the main dataset, that is stock prices, and only add supplementary data, example, new sentiment if available, right? And in right join, it is useful when the main focus is on the supplementary data and you want to include all its entries, right? And for the outer join, it is useful for combining data sets where you want to retain all data from both the sets, right? And it will having the NN values when it is not common, right? Okay, now let's understand this figure. And with this, you will be able to understand both the merge and the join method. So let's first understand the inner join. Let's say we have two data frames. One is A, another is B, correct? Because in both the merge and join, we have these four operations. So if you want to apply the inner join, what will happen? It will display only the common columns, right? Let's say in the A data frame, you have date and price, and in the B, you have the date and the ticker name. So when you apply the inner join, it will only display the date column. Rest it will ignore. So we get only the common values from both the data frames. Similarly, in the left join, what happens? It will display all the values from the A data frame, and from the B, it will only display the common value. Means in A, you have date column, and in the B, you have date and ticker. So from A, it will display both, means you will get date and the price, but from the B, you have only the common, which is date. So in the final output, you will be having date and the price, right? And right join is the inverse of left join. So you will get all the values from the B, but from the left, you will get only the common values. Similarly, in the outer join, you get everything, means all values from A and all values from B. And that simple it is. It is very simple. It is just a more practical concept than the technical. If you just close your eyes and just think in your mind that how it is happening, and then when you apply all these concepts in your real life, you will see that how easy it is. It is just a little bit confusing, but it's not difficult. You just have to close your eyes and think in your mind that how it is happening. That's it. Okay. Just now pause the video, close your eyes, and just recall these images in your mind, and you will see that you will never forget this again. Now the last one is concatenating. So the definition is concatenating appends data frames either vertically or horizontally using the pd.concat function. This operation is akin to stacking data frames. In concatenation, we just stack the data frames. Like if you have two data frames, if you want to stack them vertically or if you want to stack them horizontally, right? So you can do that with this pd.concat function, and it is also very useful. So all these three methods are very useful, and you can skip join because you can perform all the operation on the merge, but you have to have an understanding because sometimes you might want that. So basically, we will understand the merge and concatenate in detail in this session. Okay, before we start coding, let me show you some data frames and let me try to explain you how these operations will be applied on the real life algo trading datasets. Now let me quickly explain you the syntax of these functions. So the first is the merge function, and we can use this with the pd.merge. Pd is the pandas, and inside that we can provide the name of the data frame, that is prices, the first data frame. The second is indicators, right? Then we have the next parameter, which is on. So on is the name of the column, which is the common column in both the data frames. Next, we have like how you want to merge the multiple data frames. So here we want to apply the inner join, which we have just understood in the previous figure. And here you have another way perform the merge function. What you can do, you can write first the name of the table or the data frame, then dot merge, and here you can give the second data frame name, indicators, right? And then the rest is goes same. So if you apply left here, it will become the left table, it will be the right table. And if you want to perform the right join, you can just reverse these. Means you can even do with the pd.merge, and if you want, you can do with the name of the table or the data frame and dot merge. Both are right. You can just try and think which gets better with you. Next we have is the join method. So in that also it is exactly the same. You just have to write the name of the table the first, then dot join, and then the name of the second data frame, right? And also you have to pass the how parameter, which we have used in the merge also. It's same, almost same. So means we can say that we can use either this one or this one, but mostly you will be using the merge, and I would recommend that you just master the merge function, and you would not need much to use the join, but still you have to have an understanding of this join also. Sometime it might be applicable at some places. And the last one is concat. So in that also you have to write like pd.concat, then the name of the data frames. The first is prices, the second is more prices. So here if you want, you can use the other methods also, but basically the name of the first data frame here and the second data frame, you have to use a list here for the multiple data frames, and then you have to provide an axis. So 0 is when you want to merge horizontally, the stacking we can also say, and when you want to merge like vertically, right? So you can use the axis equals to 1, and the data frames will be concatenated vertically, right? So this is the axis 1, you can say, and this is axis 0, right? Even like with this type of columns, you can see that it is similar to 1. So you can remember that 1 is vertical and 0 is horizontal. Okay, now let's quickly see some data frames, and I'll show you how we can use that. Okay, so here you can see that we have this historical price data frame, and in that we have date, ticker and close columns. And also in fundamental data, we have ticker, quarter, earnings and revenue. Means we can merge both these columns based on this ticker column. This is common here, right? So you can apply the merge function and you can perform the merging operation. And if you want to concatenate, you can also do that, but there is no requirement of any common column. You can just straight away concat. Just you need to think that while concatenating horizontally, number of columns should be same, right? And also if you want to merge these two columns, you can see that we have ticker as common and date also common here. So you can see here that here date and ticker is common. So you can merge these two data frames based on the date and ticker column. And similarly, here also we have date and ticker. So you can merge and these two also. And if you want, you can merge all these three, right? And last is volume data. So in volume data also we have date, ticker, and even if you want, you can merge all of these 5 data frames. So that was the basic explanation, and I tried my best to make you understand. And I always consider everyone as a beginner, as a noob, because I was also a beginner sometime, and I know that how much I struggled while learning these things. So let me know if you want to change the way I'm explaining. Please let me know how we can improve this. Your valuable feedback is always appreciated. And now let's jump to the coding part and perform some real life algo trading problems. So here you can see that first we have to install the YFinance package. So you can do that with the exclamation pip install YFinance if you are using the Visual Studio Code or the Jupyter Notebook or any other notebook software. And then you have to import with the command import YFinance as YF, and then you can use the YFinance. So YFinance is the Yahoo's finance repository, you can say, right? And here is the theoretical part. So you can just go through if you need. And these are few examples. And this is the code to import the data from the Yahoo Finance, and also for some of the tables as Yahoo do not have the data. So for that, we just created the synthetic data, right? So you can see here that this generate trade orders is synthetic data, and also this signals also synthetic, correct? Okay, now let me quickly show you the data frames. The first is historical price data. You can see here. The second is fundamental data. Third is trade orders. Fourth is strategy signals. Fifth one is the volume data, right? So you can see here, basically in volume, we have date, ticker, and volume. In signals, we have date, ticker, and signals. So in trade order, we have order ID, date, ticker, quantity, and price. And in fundamental data, we have ticker, quarter, earnings, and revenue. So the data of this quarter is not available in the Yahoo Finance. So that's why it is NN values. And the first is historical price data. So we fetched this data from the Yahoo Finance. So basically you can see here that we have these two columns as almost in all the data frames. So we can perform the merging operation on these basically, right? So let's start. So what we will do here, first we will understand the join and concat. And after that, we will deep dive into the concept of merging, because that is the main agenda of today's session, right? So let me show you quickly. So before that, I'll just note down the name of tables here. So first is, or here we can do, first is historical. Then we have fundamental, volume, and trade. Then volume, and then trade. So let's say if you want to join this historical price data and this fundamental data. So for that, what you can do, you can just write the name of the first table, that is historical price data, then write join, and inside that you have to provide the right data frame. So here we can say it is fundamental data. So I'll write fundamental data, and then you have to provide how, like what should we perform. So let's say we want to perform the inner join, right? So I'll write inner, and so in inner what happens, we will get only the common values. So when we hit shift enter, you will see that it gives us a, so now you can see that we are getting this error which says column overlap but no suffix specified, right? Index, ticker, and D type object. So for that, what you can do, we know that, let me show you the, let me remove this, and I'll again, first let's check the historical price data. And here, this is the data frame which have date, ticker, and close, but in the index we have the default index of the data frame. Similarly, in the fundamental data, we have ticker, quarter, earning, and revenue. So we have to specify that on which column you want to join this data frame. So for that, what you can do, you can simply go here and first set index here. So set index, and in historical price data, you can set index as date and ticker. So I'll just write date and ticker. If you remember, when we understood the theoretical part, we have seen that this join merge the data frame based on the indices, right? While merge can do with the column name also and the indices also, right? And here also we have to set the index. So I'll write set index, and here we can give the index as the ticker, right? So I'll just copy here and paste it here. So now when I hit shift enter, you will see that it has been merged, right? And all the common rows is being displayed here, right? So that's how you can use the join. And if you just change here from inner to left, then all the values from the left will be displayed, but from the right, only the common values will be displayed. So when we hit shift enter, you will see the value. You can perform on right also, same, right? You can see here. And also you can perform an outer. So in outer, you will get all the values, right? And you will see that you are getting all the values. So that's how you can use the join method. To be very honest, I prefer to use merge method because the merge can perform the similar operation, but that has the advantage of common column also, right? It can like perform on the column and both the indices. So that's why that is much better, I think. But sometimes you might need this. So just be aware of this function also. Let's understand the concatenate. Now let's understand the concat. So I have told you earlier that, so in concat, you can merge the data frames based on their positions. Like if you want to merge the horizontally or vertically. So for that, what you can do, let's take these again, the historical price data and the fundamental data. So we know that, let me, historical price data and shape is 204 rows and 3 columns. And for the fundamental, we have 6 rows and 4 columns. So if I want to merge these horizontally, so for that, what we can do, I'll write pd.concat, and inside that we can provide historical price data and the fundamental price data, right? So when I shift enter, it says me concat takes one positional arguments but two were given, right? Actually, we have to provide the name of the data frames in a list. So I'll just give a list, and now when I shift enter, you will see that it has been concatenated, right? Now the rows are 210 and number of columns are 6. And why 210? Because I've shown you earlier that 204 plus 6 is 210, and then again 3 plus 4 is 7, but we have 6 only. Why? Because one column was common. This ticker column was common. So only we have the ticker as only one column. Correct? So that's how you can do that. But if you can observe, we have one problem here. The index is repeating. On the top, we have the index of this first data frame, and on the below, we have the index of this second data frame. Sometimes it is only required, and sometimes we don't need this. We need a range index. For that, what you can do, you can simply write here a parameter that is index, that is ignore index is true. By default, it is false. So you can make it true. And when you do that, you will see that we have a range index, right? From 0 to the last row, correct? Okay, now let's say if you want to preserve the index of the original data frame. So for that, what you can do, you can simply, let me copy and paste this command. I'll just remove this ignore index. And here you can give another parameter, that is keys. You can pass a list. Okay, in key, you can give, let's say first hist key, right? And then you can give, second one is fundamental key, right? Not key, fundamental data. Historical data and fundamental data. And when you do that, and when you hit shift enter, you will see that we have preserved the original index. You can see here, the first one is historical data. Then again, second one is the fundamental data, right? This key is for the first data frame, and the second key is for the second data frame. That's how you can preserve the index. Actually, if you can see here, it is known as the multi-index. The first index is the keys, and the second index of the original data frame. It is known as the multi-index. Let me write here. Actually, we will learn this whole concept in the next whole session. It will also be a very, very important and useful session. So in the next session, we'll cover the multi-index. Let's say if someone asks you that I want only this data, the fundamental data from this multi-index data frame. So for that, what you can do, you just have to assign it a variable, let's say combined df, okay? And then I'll go here in the next cell and I will use the LOC. We have learned this previously that whenever we have an index in the labeled form, we can use the LOC, right? Here, I'll give a tuple. So in tuple, I will pass the historical data. So hist data. And now when I hit shift enter, you will see that we have only the first data frame. If I want the fund data, I can just change it from hist to fundamental and you will get the fundamental data. So it's very easy. And also, let's say if you want only the second row, right? So for that, you can just give here the only second row values. Okay. Now let's understand the concat function. So in concat, I have explained you already in the theoretical part that we can concat two data frames horizontally or vertically. So by default, when we do not mention any axis, it is 0. And if you mention 1, then it is merged vertically. So let me show you how. So here we'll take two data frames. First is historical price, which has a shape of 204 rows and 3 columns, and fundamental data, which has a shape of 6 rows and 4 columns. Let me show you. So here you can see that the historical price data, which has 204 rows and 3 columns, right? This one, 3 columns. And again, this fundamental data has 6 rows and 4 columns. So let's understand the concat. So pd dot concat, and here you have to provide the name of the data frames. So first is historical price data, and the second is fundamental price data. So when you hit shift enter, you will see that you get an error. Why? Because here you have to pass a list. So what I will do, I'll just pass a list here. And now when I hit shift enter, you will see that it has been concatenated. And by default, it is horizontally, correct? You can see here, it is horizontally. Means earlier we had, in the first, we had 204 rows and 6. So means it became 210. And again, 3 columns and 4 columns became 6 columns. Why? Because one column was common, the ticker one, correct? So it became 6 columns. Now, if I just change this axis from 0 to 1, you will see that it has been merged vertically. So when I shift enter, so you can see here that the number of rows remains same, but the number of columns becomes 7, right? 1, 2, 3, the first data frame, 3 columns, and then the 4 columns. So means if you keep the axis 0, the rows will be added, and if you keep the axis 1, the columns will be added. Or again, for the simplicity, if vertical means like the 1 and horizontal means 0. So that way you can remember, just remember that 1 is vertically standing. That's it. Okay. Now, one more thing I would like to add here, that I'll just copy and paste it here. And let's say we do not mention any axis. So by default, it is 0. So it will be merged horizontally. And here, if you observe that we have 2 indexes from 0 to 204, then again 1 to 5. So sometimes it is required, and sometimes what we want, that we want a straight index, like from 0 to last, whatever the number of rows, right? The 210 means from 0 to 209. So for that, what you can do, if you want, you can just add another parameter here, that is ignore index true. So by default, it is false. So when you make it true, you will see that we have an index from 0 to the last row. And sometimes what happens, that you want the original index of the data frame. So for that, what you can do? For that, you have a simple method, that is you can provide keys here. So when you provide keys, you have to pass a list. So the first key, let's say we have the hist data, right? And second key you can give as the fundamental data. So when you hit shift enter, you will see that we have 2 indexes. In the first index, we have the first data frame, that is historical data. And in the second data frame, we have the fundamental data. So means now we have 2 indexes. The first is the label index and the second is the integer index. Means we can also name it as the multi-index, which is itself a very big and very important concept of the pandas, which we will study in the next session. We will spend the whole session on the multi-index because that is very, very important. So what I will do here, I'll just write here the multi-index. Okay. Yeah. Okay. Now let's move to the main agenda of the session, that is the merge method, right? Okay. Now let's understand the merge. For the demonstration purpose, what I did, I fetched 2 data frames. First is historical price data and second is fundamental data from the Yahoo Finance. Okay. So let me show you. This is historical price and this one is the fundamental price data, right? So in historical price, we have 5 columns: date, ticker, close, earning, and revenue. And in fundamental data, we have ticker, quarter, earnings, revenue, and PE ratio. So let's say if you want to merge both of these data frames. So for that, we have seen that what we can do, we can simply apply the historical price dot merge method. And then inside we can pass the name of the second data frame, that is fundamental data. Right? Then we have to specify. So what happens when you don't specify? It automatically checks all the common columns and it will merge that. So when I hit shift enter, it says that you are merging on int and float columns where the float values are not equal to their int representation, historical price data.merge. So for that, what we can do, we can actually change this value to like from float to integer or from integer to float. But for now, what I will do, I'll just specifically mention that I want to merge on the column name ticker, right? So for that, you have to mention the name of the column ticker. And now when you hit shift enter, you will see that these data frames have been merged on the column ticker. Here we had 5 columns, and in this we had also 5 columns. So now we have total 9 columns. Why? Because the ticker column is common in both the data frames and one column has reduced, right? So here we can say that by default, the merge method perform the inner join operation. Let me take another example. So I'll go here and I'll paste it here, and instead of inner, I'll make it as left. And we have seen that in left what happens, it will display all the columns from the left table, and from the right it will only display the common values. So when I hit shift enter, you will see that we have all the values from the left, right? And from the right we have only the common values. So you can see that we have 136 rows and 9 columns, and from left we have all the values, and from right only the common values, right? Then again we can perform the right operation, and the right join is the inverse of left. So when I write right, it will display all the values from the right, but from the left it will display only the common values. So how you can identify here, if you can see here, by default, if both the data frames have common name, the X is for the left data frame and the Y is for the right data frame. So if you want to make it something different, what you can do, you can add here suffixes. So let me show you how. So I'll go here and I'll add suffixes, and here you can give like this. Second is fundamental, so you can add funda. Simple. This means that no suffix for the first data frame value, that is X, and for the second one we'll be having underscore funda suffix at the end. So when I hit shift enter, you will see that for the first, that is the earnings and revenue, there is nothing, but for the second one we have funda at the end. Correct? Because in inner join we have only the common values from both the data frames. Similarly, you can add this at all the operations. Here also if I add suffixes, so you will see that this X has been removed and this Y has been replaced with funda. So when I hit shift enter, you will see that. Correct? Here also we can do that and it will be changed. And the last one is outer. So in outer we will be having all the values from both the data frames. So when I change it to outer, you will see that we have all the rows, right? It is 138 and 9 columns and all the values we have. Okay, now what we will do, we will perform some real life scenario based questions on the algo trading, and I guess we will cover that in the next session, right? So we'll have another supplementary session, and in that we will practice all the questions. Okay, so that is for the day, and we'll see you in the next video. Until then, bye bye, take care, have a nice day.